In this video, we will examine the steps to write a balanced chemical equation. So we will start out with an example. Our example is lithium and sulfur react to make lithium sulfide. The first step is we want to write the word equation. So what this is it's going to list the reactants and the products. We're going to separate them with an arrow. So in our example, lithium and sulfur react to make lithium sulfide. So lithium plus sulfur are our two reactants. And they are going to react, so we're going to show that with an arrow, to make lithium sulfide, which is our product. So this is a word equation, just simply taking our sentence and putting it into something that looks like a chemical reaction. Our next step then is to write a skeleton equation. So what this does is it takes the word equation and creates chemical formulas for each element or compound within our word equation, but doesn't balance the chemical equation yet. So remember, we had lithium plus sulfur. So lithium, it's not diatomic, it's just Li. And sulfur is just S, and it reacts to produce lithium sulfide, which would be Li2S. Okay, so this is our skeleton equation. It's just taking our word equation and writing out the chemical formulas for each of our reactants and products. The next step in balancing involves counting the number of atoms in the reactants and the products. So let's just rewrite our equation here. Li plus S reacts to give Li2S. If we look at our reactants, there is one lithium and one sulfur. In our products, there are two lithiums and one sulfur. Okay, this is a fairly easy example, but they can get a lot more complex. We now want to multiply the formulas by the appropriate coefficients to balance the number of atoms on each side. So from our table and counting our atoms, we saw that the sulfurs are balanced. There's one on each side. However, there's two lithiums in the product and only one lithium in the reactant. In order to balance that, we're going to put a coefficient, so a number in front of the element, that will produce the same number of lithiums on both sides of the reaction. So for this example, we need to put a 2 in front of the lithium on the reactant side in order to balance and get 2 lithiums on the product side. So this is now balanced, and you can go through and double check and count the atoms on both sides again to make sure that you have the correct balanced equation. Let's do one more example then. We're going to do calcium metal and water combined to produce calcium hydroxide and hydrogen gas. So starting with our word equation, calcium metal we can write as just calcium, and water. If you want to write dihydrogen monoxide here, you can. And that's going to make calcium hydroxide and hydrogen gas. Now, if you know the states, you can put those into when we switch to our skeleton and balanced equations. So calcium metal, metals are always solid, so we're going to put in our solid there, plus water is going to react to give calcium hydroxide, which is Ca bracket OH bracket 2, and hydrogen gas. You got to remember that hydrogen is one of those diatomic molecules, so it's going to be an H2 gas. Now what we want to do is count the number of atoms on each side. So on this side we have 1 calcium, we have 2 hydrogens, we have 1 oxygen. On this side we have 1 calcium, we've got 2 hydrogens from here and 2 hydrogens from here, so that's 4 hydrogens total, and we have 2 oxygens. So what you could see is that the calciums are balanced, but the hydrogens and oxygens are not. So we need to double the number of hydrogen and double the number of oxygen on the reactant side. We can do that by putting a 2 in front of the water. And if we double check now, there's now 4 hydrogen and there's now 2 oxygen, which means that we are balanced.